The Equifax data breach happened in 2017 and is considered one of the biggest hacks in history. The credit reporting company suffered multiple security failures that resulted in attackers being able to access sensitive data like addresses or social security and driver license numbers of over 134 million of their customers. The attackers had access to Equifax systems for 76 days before the breach was discovered. A vulnerability in the customer complaints page initially made the whole attack possible by allowing the hackers to perform an XML eternal entity, or short XXE attack. XXE attacks are currently listed 5th on the OWASP top 10 list of web security vulnerabilities under the category security misconfiguration. In this video, I will explain what an XXE attack is, how it is performed, and I will present some countermeasures that can be initiated to prevent such an attack. What is an XML external entity attack? A XML external entity attack, or short XXE, is a vulnerability in a web application that is targeted at the XML processor, also known as XML parser, of the application. This vulnerability can be exploited to perform actions like accessing backend content and services, as well as attacks like a denial of service. It can also be used to perform a so-called server-side request forgery. If you want to learn more about that, I have another video about this topic which you can find via the link in the video description. To better understand this type of attack, it is important to first learn some key features of XML. XML stands for Extensible Markup Language and is used to store data and transport data. A XML document kind of looks similar to an HTML document, as it also uses a similar structure and tags and data provided in angle brackets. XML entities are comparable with variables in a code. In this example, there's an entity element with the name bar, which represents the word world. If the XML document then contains any places where $bar semicolon is used, the parser replaces the entity with the word world. A XML external entity can be described as a XML entity that has no predefined value within the document type definition, as in the example I just described. Rather, it gets its value declared from an external source, and by tempering the entity's definition or introducing a new one, attackers are able to manipulate the XML parser, resulting in different attack scenarios depending on the type of attack. If you want to learn more about XML, the parser and entities, the XML learning path on WSV Schools is a useful resource for you to check out. I'll put a link to that in the description of this video. There are a few different types of XXE attacks, but in this video I want to focus on the most important ones. Like previously mentioned, XXE attacks can be used to inflict a denial of service, or a server-side request forgery attack, as well as the exfiltration of data. To perform a denial of service attack via XXE, attackers use the option to embed XML entities within other entities. This way, they create a recursive structure of entities that call for other entities, and by this, are able to generate a large amount of output data with rather little input. The unusual large output can overload the XML parser's memory, which would result in the overload of the web application server. An example for that can look similar to this. Now, by adding even more layers to the entity definitions, the resulting entity can become so big that no typical XML parser would be able to process it without overloading. An attack like this is also called billion loss attack. Aside from denial of service attacks, a XXE vulnerability can also be used to retrieve files or other data from the server. In order to perform an attack like this, the attacker has to modify or introduce a XML request containing an external entity that points to the path of the file they want to access. Alternatively, they can also use an existing data value in an XML that is returned somewhere in a response of the application. As an example, a payload retrieving the etc. password file from a server could look something like this. As mentioned previously, XXE vulnerabilities can also get exploited to perform a server-side request forgery attack. If you're not familiar with server-side request forgery, I advise you watching my video on that topic, as I will only briefly cover it here. In this case, the attacker defines an external XML entity that contains the targeted URL, which then gets used within a data value that is somehow returned in a response from the application. By doing that, the attackers are able to open a communication with the backend system or the application server and might be able to bypass the access control of the application. Often, instances of XXE vulnerabilities are not as easy as in the previously mentioned examples. Many times, the applications don't return the requested value from an XXE attack simply in a response, which would result in a blind XXE attack. In this case, the attacker has to perform additional techniques to retrieve the data, for example, in the form of an out-of-band XXE attack, where the requested data is redirected from the application server to a different system that is controlled by the attacker. Alternatively, the attacker can try to trigger the XML parser to return error messages containing the requested data. In this video's demo, I will further demonstrate how a file exfiltration via XXE can look like, based on the previous explanation. For this, I will use a XXE lab provided by the Portswigger Web Security Academy. If you want to check it out yourself, I will put a link to the different XXE labs in the description. The page provides deliberately insecure websites where you can perform attacks against those web applications in a legal and safe way. To find a spot where a website might be vulnerable to XXE, we don't have to dig that deep, since most of the time the HTTP traffic of a web application contains some kind of data in an XML format. So we have this online storefront, and for each product they sell, let's just take the picture box. There is an option to choose a certain city store and check if the product is in stock in that store. Now we're going to choose any random store, just go by London, and we're going to send the check stock request to the server. So in the next step, we're going to open burpsuit and find the post request that was made when we hit the check button. If you want to check out burpsuit, I will also put a link to that in the description. So here we have the post request, and if we just scroll a bit down, we can see that the request contains some XML elements here. So to modify the XML request, we can now use burpsuit's repeater by sending the request here. By that, we're going to right-click on the request and just go to send to repeater. Now we can open the repeater tab up here and we can see the request. Now with the repeater function, we're now able to make some changes to the request and resend it. So first we're going to add an external entity definition right after the XML declaration. And we're going to do that by adding this, like here, doc type test, and we're going to put an entity that is called XXE. That points to the etc. password file. Below that, we have to replace the product ID, which is right now 2, because we chose product number 2, with our entity by putting ampersand XXE semicolon. And in the last step, we're just going to resend the template request by clicking send. In the response, we can now see that it not only contains the invalid product ID error, but also down here the whole contents of the etc. password file. Now, this was a very simple example of how the exploit of an XXE vulnerability can look like. Since the lab I used for this demonstration was rather easy to crack, real-life examples might look a little bit different and require additional steps, but I hope it helped you to better understand this type of web security attack. As many other vulnerabilities that can be found in web applications, the exploitation of XML internal entities can also result in some highly damaging consequences like a denial of service, the exfiltration of sensitive data, or other attacks like a server-side request forgery. Luckily, since the origin of this attack lies in the external entities used in XML, the most efficient way to secure a web application is by simply disabling those external entities completely. Depending on the parser and the used programming language, there are different ways to disable external entities in your code. Especially in C or C++, XXE occurs relatively often when the parser libxml2 is being used, as an older version of this parser allows external entities by default. By version 2.9, this feature was disabled by default in a patch, but if you're using earlier versions, you should update the version or disable it manually. To do this, remove the options XML parse noEnd and XML parse dtd-load from the enum XML parser options. Those two options are being used to expand entities and replace them with new text, as well as load any external entities. Also, here is a list of APIs that you should check and make sure that those two options aren't defined in their parameters. I will also put a link to this list in the description of this video, so you don't have to take a screenshot right now. Same as C or C++, iOS also uses libxml2 as an XML parser. As stated before, version 2.9 of libxml2 has external entities disabled by default. Unfortunately, any iOS versions below iOS 6 still use older versions of libxml2, where you still have to manually disable external entities. To do that, you can use the iOS feature nsxml document. That is a document type that was built on top of libxml2. You simply have to use the command nsxml node-load external entities never when you want to create a new nsxml document. Next, applications written in Java that use XML libraries are a huge target for XXE attacks as well, since almost all Java XML parsers have external entities activated by default. The most commonly used parsers are Document Builder Factory, Sex Parser Factory, and DOM4j. And for all of them, you can use the same techniques to prevent any vulnerabilities caused by these external entities. This is an example for Java code that would be vulnerable to XXE attacks. But by adding the following code, you can simply disable doc types and by this, disable external entities. Last, some of Python's most popular XML parsers like E3 or Genshi have external entities disabled by default as well. For the rest of them, you have to use an additional package like diffused XML, which is fully compatible with any parser you're using and grants sufficient protection against attacks exploiting external entities. I will put a link to the OWASP cheat sheet where you can find all the mentioned code examples, as well as lists of packages and parsers that might be vulnerable to XXE in the description of this video. I hope this video gave you a good overview of XML external entity attacks. Attacks like this can lead to multiple possible types of consequences, like the exposure of sensitive data or denial of service attacks. Luckily, if you know about this kind of vulnerability, like you probably do after watching this video, it is very easy to avoid occurring in your application. Just follow the needed steps to disable external entities depending on the XML parser you're using, and your application should be safe from XXE attacks. You will find all the links to the resources and websites I mentioned in this video in the description, and if you're interested in learning more about web security, feel free to check out my other videos. Until then, I wish you a delightful day and see you soon in the next video. Goodbye.